these do. And I need to oversimplify things here. We will come back and fill in some of the details later. But essentially, you have an opening and closing set of curly braces, and those define a code block. And code blocks typically have names, and they have purposes. So in this particular case, we have a first code block, and this code block has the name main. Okay, and this particular code block is known as a method, and this particular method by convention is the very first method that's called whenever your application is executed. All right, and so I don't want you to worry about these other words, static and void, and even the string and the args for right now. We'll talk about those later on. But this entire code block here, as well as the line above it, they define something called a method. And a method is simply a block of code that has a name. Now later on, you're going to come to realize that a method is so much more than that, but I want to use that as a working definition as we're getting started here. The method has a name, and when you have a name, you can call a name and say, I want you to execute. All right. And so we'll talk about methods again a little bit more in a little while. This main method lives inside of another set of curly braces, and that set of curly braces also have a name. The name is program. It's a class called program. And so you can think of a class as simply a container for all of the methods of your application. You can kind of keep the methods that are related to each other in separate classes. Now, what do I mean by related to each other? Well, that's really for you, the developer, to decide. As you get deeper into programming, you're going to come to understand the thought process behind organizing your code. But that's a little ways off for now. Just trust me on that. Now, I said that a class was merely a way to organize your methods. It is so much more than that. And again, I'm way oversimplifying this as we're getting started here. But the main takeaway for right now is that that code is organized in curly brace containers, and you have some blocks of code that reside inside of other blocks of code. And to kind of emphasize that again, here we have another set of curly braces, and this set of curly braces has a name as well. In fact, it's a namespace called Hello World, which happens to be the name of the application that we gave it. Again, keep things extremely simple here. A namespace is just another way of organizing code. Again, at some point it becomes so much more than that, but let's keep it simple for now. So let's take a look at these lines of code and kind of illustrate these ideas about namespaces that contain classes that contain methods. Here what we're doing whenever we're calling console.writeLine is we're actually making a call into the .NET Framework class library. Remember, it's that library of code supplied by Microsoft, and we're saying in that entire library there's a book, and there's a chapter inside of that book that I want to reference. All right. So in this case, we're saying that book is the console book, the class, and I want you to look at the chapter named WriteLine that has the definition for this method. All right. Hopefully that analogy works for you. But we're looking inside of a library, defined a class, and we're going to call a particular method inside of that class. And by using its name, we can execute all the code that was written inside of that method. Same with the method that we're calling below it as well. Notice that there is a period that we use between the name of the class and the method name, and we use that. It's called a member accessor. It allows us to access a member of the class, or in other words, now that we know what the book is, we can find out what chapter we want to reference. Okay, hopefully that analogy works for you. Now notice also that both, whenever we call the WriteLine method and the ReadLine method, that they both have parentheses following them. Now, in the case of the WriteLine method, we're actually sticking something in between the opening and closing parentheses, whereas in the ReadLine method, we're not. But essentially, those parentheses are saying not only do we want to reference that particular class method name, but the parentheses mean I want you to actually invoke it, execute it, do it now. Okay, so that's the purpose for those parentheses. Now, we can say do it now and pass in information. Do it now with this stuff, with this argument. So we're passing in an argument to the write line method and saying, we want you to do it, write this to screen, and here's what we want you to write. So it's an input parameter to the method named writeLine. Okay. Now don't worry, we're going to come back to the notion of methods in the future, as well as passing values into a method like we did as we passed in the literal string hello world into our method here. Just know that whenever you see parentheses after a given word in your code, you should be thinking that that code is being called right now as we step through the execution of the code. Next up, let's talk about the semicolon. We've already kind of explained it in the previous video, but just to kind of emphasize it, notice that almost everything, even these statements at the very top, have semicolons, with the exception of whenever we're defining a namespace, a class, or a method. And we said at the time that the semicolons are actually similar to the period or exclamation mark or question mark at the end of an English sentence. It completes a thought in C#. Now, some programming languages, like Visual Basic, for example, they don't really have this idea. They only allow one complete thought per line of code. However, with C#, you could do this, what I'm about to do. Watch. Okay, now I have both of those lines of code on a single line. All right, and if we run the application, it'll work just as it did before. All right, so the way that you separate or indicate that you have two different complete thoughts is through the use of a semicolon. Furthermore, we could put lines of code on separate lines like this. Now, it wouldn't make sense in this case because the line of code is so short. It actually makes it difficult to read, but sometimes when you have a very, 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 very long line of code, you'll see me split that line of code into multiple lines, and still the application will execute. Now, in other programming languages, you wouldn't have that behavior, all right? Because really, white space and line feeds and things of that nature, they don't matter to C#. The only thing that really matters is to indicate a complete thought is a semicolon at the end of the line. Let me go ahead and get rid of all that. And the other thing that I want to mention here that you may have noticed is the level of indentation that you get automatically from Visual Studio. Now, that's completely optional, and Visual Studio nudges you in the right direction, but essentially, even if you were to kind of come out here, and we'll use the tab key several times and write the word console.writeLine, something like that, and notice that Visual Studio re-indented it for us. Why do you suppose it did that? Well, many people believe that indentation helps the readability of the code so that you can see what code container, where code resides inside of the other curly braces inside of your application. All right. And so kind of along those same lines, for readability's sake, notice that there are many different colors that are used as text inside of this text editor window. You have these royal blue colors, and these are my default colors. Yours might look a little bit different, but by default, I think you have some royal blue, some black, you have aqua color here. This is a dark red. You have some light gray and light blue. All right, and all of those are used to help you identify the parts of speech, I guess you can say, inside of the code that you write. All right, we'll talk more about that as we talk more about the syntax of C# in an upcoming lesson. Okay. All right, so now that we've talked about the code that we wrote and its position and formatting and white space and tabs and all that sort of stuff, what I want to do is stop right now for this video, and in the next one I want to talk about the files themselves, the file that we typed our code into, how that relates to projects and even solutions, what happened when we saved our project, what happened when we actually ran our project, and so we'll do that in the very next lesson. We'll see you there. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Next, we're going to talk about how code files are organized into projects and solutions, and then where you can actually find these projects and solutions on your hard drive. So whenever we created a new console project, the program.cs file was opened for us automatically in the main area in Visual Studio. And that's one of the things that project templates do for us. Whenever we choose File, New Project, and we see the New Project dialog, and we choose a project template, they provide a great starting point for the type of application that we want to build. It includes files with boilerplate code, important settings, and other resources that we might need whenever we're building that type of application. So as you can see, we're working inside of this file in the main area, and there's a series of tabs. Again, this isn't intended to be an overview of Visual Studio, but it's important to note that the names of the code files that you're working on are contained inside of those tabs. And if you take a look over to the right-hand side, here is the Solution Explorer window, and it has a tree-like structure of all the items that are kind of contained inside of our project. Now, again, as I said at the outset of this course, this isn't intended to provide a tour of Visual Studio per se, and there are other resources on Microsoft Virtual Academy that can really help orient you to using Visual Studio and the various windows and functionality that it contains. But the Solution Explorer is probably the most important part of Visual Studio next to this main area where you'll usually see the text editor and other designer windows. So simply put, the Solution Explorer is our main navigational device to the other files and settings that comprise our program. So you can see here that there is a program.cs file. Now if I were to close the program.cs tab in the main area, I can always get back to it and open it up again by double-clicking it inside the Solution Explorer. All right, you can see it's open once again. Now files and important settings are organized into a concept called projects. So you can see here this word hello world is actually a project. You can see there's a little C# icon next to it letting us know that this is a C# project specifically. And projects get compiled into a single .NET assembly, which we'll talk about later. Furthermore, one or more projects are organized into solutions, and you can see in the Solution Explorer we have one solution here at the very top, solution also named Hello World, that contains one project. Now, in many cases as you're getting started, you're only going to have one project inside of one solution. But as you come to build more complex applications over time, it's highly likely that you're going to need to manage multiple projects that are somehow related. Now again, the reason might not be obvious at this point, but as you continue to learn C# and how to build more complex applications for large companies or for yourself, this becomes a crucial code management strategy. But just for now, accept the fact that there's this extra layer of a solution, and one solution can contain one or more projects, and the projects will contain then all of the code files and the settings and the like that will be used to create an actual executable program. So trust me, these concepts will become more important after we get past the basics. Now the big question at this point should be, where are all these projects and solutions and files actually stored on your hard drive? I mean, can we see them? We can see them in the Solution Explorer. Where are they actually on your hard drive? Well, when we created this Hello World project, we merely provided the name of the project, you'll recall, and then I said go ahead and accept the other defaults. By default, Visual Studio will put your projects into your Documents folder. So if you take a look here and we navigate into the Documents folder, it will put your projects into whatever version of Visual Studio you're currently using. So you can say I have side-by-side Visual Studio 2013 and 2015. We're using 2015 for this series, but it could be a future version of Visual Studio. you'll look in that particular folder for your version of Visual Studio. And as we drill in, there will be a projects folder, and as you drill in, you can see that by default, when we created our new project, it put it here in our document / Visual Studio whatever version / projects folder. Okay, so as I add more projects, this obviously will be filled up with folder names for those projects. And it's important to note that whenever you create a new project, you don't have to create it and put it right here. You can put it anywhere. And so to keep things organized, you're typically going to keep them in the same place. Now, furthermore, you can actually open up a project that's saved anywhere on your computer as well. So, for example, I have this, in this course, I'll supply the projects. After I record the video, I'll zip them up and you'll be able to download them and then open them up on your own hard drive and then walk through them and to better understand them. And so just to kind of demonstrate how you do this, I have this project called, is zipped up into a file called example.zip. And so what I'm going to do is actually right-click this and select Extract All. And then in the Extract Compress Zip folders, I'm just going to put this on my root. So C:/example, and then click Extract. And so now you can see that on my local hard drive, I have an example folder. And inside of that folder, there is another folder with a file called example.sln. I'll talk about that in just a moment. But I can either double click this .sln file to open up the solution inside of Visual Studio, like so. All right, or I could go to File, Open, Project Solution, and then navigate to that directory using the Open Project dialog, if it'll let me. Okay. All right, and unfortunately it's a little bit too large for the recording area, but then I would just simply select the solution that I wanted to open from this dialog and then click the Open button. All right, let's go ahead and close that. And let's shut down this copy of Visual Studio. And I want to get back to where we were just a moment ago in our Documents, Visual Studio, in my case, Visual Studio 2015 Projects folder. And here are a list of all the solutions in our project folder. And so just kind of want to walk our way through this. This first folder here will contain our solution files. So there's this .sln file, which is a solution file. It contains information about all the projects that are under this umbrella solution. Okay, and we could actually open this up and look at it inside of Notepad, and it's simply just a configuration file. There's nothing all that special about it. You certainly don't want to make any changes to it, but it's going to have information about all of the locations for the various projects that are associated with this solution, any global settings, and some of these things won't really be useful to us until we get deeper into our understanding of compilation and things of that nature. But inside of the solution folder is a second folder which is actually going to contain the project files. And so here we have a hello world.csproj, which is the a project file, the C# project file, and this file will contain, let's open that up as well with Notepad. It'll contain references to things like all the files that are associated with this project and any of the settings and any other metadata. Again, information in here that you certainly don't want to edit, and you don't want to accidentally make any changes to it whatsoever. But I just wanted to make you aware of it, that there's really nothing magical going on. There's just these configuration files that contain information about your project, and as you make settings on the project level, those will be saved inside of that CS project. And then finally, there's this bin folder here, and the word bin typically is short for binary, which denotes that this is where a binary version of your application will be stored. So the process of compilation, it takes your source code, and which is human readable, and it's going to convert it into a format that is machine readable or understood by a machine, your computer. And so if we were to take a look inside of this folder, we would see that there is a debug folder. And so this folder is created for us whenever we started debugging our application. It creates a temporary version of our application for debugging purposes, which we'll talk about later. If we drill into that, you'll see that there is actually an executable file and several other helper files for the purpose of debugging. We'll talk about these later. If I were to double click the hello world.exe, it actually executes our application. All right. And so, you know, compiling your code into a working application is the end goal, but I don't want to talk about compilation just too much yet, or about creating a debug version versus a release version of your .NET assembly, of your compiled code. I think you're going to get a better appreciation for those ideas after we get past some more of the basics. So what I want to do is just stop our conversation about the bin directory right now, and we'll come back to that a little bit later. But you're doing great. Let's continue on. We'll start learning more C# now that we have some of these tangential topics out of the way. Or I'll see you in the next lesson. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my videos for beginners, please visit me at devu.com. Now in this lesson, I want to get back into talking about C#, the syntax, and we're going to talk about declaring variables, how to choose the right data type for your new variable, and then also how to initialize variables with values. So to begin, let's take a look on screen. If you've ever taken an algebra course, hopefully you've seen something like this, where you're asked to solve for the value of x. And hopefully without a lot of thought, you're able to see that x equals 7, right? So using that same thought process, take a look at this little snippet of code on screen. X equals 7, y equals x plus 3, and then we're going to do a console.writeLine with the value of y. And hopefully you look at it for a moment using your existing knowledge of algebra, and you think to yourself, well, then it's going to output the value of 10 to a console window, right? Exactly. And so my point is that C#, first of all, is human readable. It's got a few things that might be a little foreign to you, like the semicolon at the end of the line. However, for the most part, I'm willing to bet that as we go through this series of lessons, you'll be able to understand what the code is doing, for the most part, even before I explain it to you. So it's really not that hard. And then secondly, it's probably very similar to things that you've done in the past, like working with math and algebra and things of that nature. And so if we're looking at the C# code, the x and the y in this context are referred to as variables. And a variable is simply, under the hood, a bucket, I guess you could call it, in the computer's memory. And you put things in buckets and you dump things out of buckets, right? And so we can put values into a given bucket in the computer's memory, and we can retrieve the value out of that bucket. We can even replace what's in the bucket with something different, right? And so that is what you use a variable for. And so this particular situation that we see on screen, these buckets are just holding numeric values. However, we could create buckets that are just the right size for almost any type of information, whether it be individual alphanumeric characters or strings of characters, strings of alphanumeric characters, like even entire sentences and paragraphs and even books. We could also create buckets that are just the right size for dates and times, buckets that are just the right size for really massive numbers, or even create buckets that are just the right size for numbers that have a lot of values after a decimal point. Now, in this case, what we would expect to see here is that these two buckets, the bucket that's labeled X and the bucket that's labeled Y would hold numeric values because we want to add numeric values together, right? And so we know that, but how do we express that intent in C#? The instructions that we write in C# will ultimately, after a compilation step, they will ultimately be executed by the .NET runtime that we learned about in a previous lesson. And part of its responsibilities are to make sure to allocate memory for our variables in memory to hold the right kind of data. So here we have two data items, an X and a Y, and we have to tell the runtime that we want to allocate some space in memory that's sufficiently large enough to hold numeric data like the type of data that we want to work with here in our application. But how do we do that? Well, that's the topic of this lesson. So to get started, what we want to do is create a new project. And here again, I'm going to go to File, New Project. We will go to the New Project dialog and make sure we select the Console Application Project Template. And here we're going to rename this and call this project Variables, and then click the OK button. And Visual Studio goes to work, uses that template, and creates a new solution with a project. And as you can see on screen, here we are back in our familiar program.cs. Obviously, we want to work inside of our static void main in between the opening and the closing curly brace, just like we learned about in our previous lesson. All right. So before we get started, there's one big takeaway from this lesson, and that is that a variable is simply a bucket in memory that you can put data into and retrieve data out of. But we have to tell the compiler, we have to tell the .NET runtime what size of buckets that we want to create. So we have to declare our variables. We have to create those buckets and then give them some label that we can refer to them with from that point on. Now, before we get started here typing some code, all the same rules apply in this video that applied previously. So you have to type the code exactly the way that I type it. Take the time, develop the skill of identifying differences between even small differences, different in capitalization or in spacing or the various special punctuation marks that we use while we're writing code. Develop that skill to identify the differences between what I write on screen and what you're writing in your copy of Visual Studio. All right, and if you see a little red squiggly line, you already know that there's going to be a problem there, right? So that gives you the clue necessary to go and focus either on that exact character or in that vicinity and use your detective skills to figure out what it is that went wrong. Okay, so now let's go ahead and we're going to create two buckets, two variables, and define them in such a way that they're going to hold numeric values. So we'll start with int x and int y, and it's as simple as that. So here, to borrow the explanation that we used earlier, we are asking the .NET runtime to allocate space in our computer's memory sufficiently large enough to hold numeric values. Now we're asking it to create these two buckets, and eventually we're going to put values into them and read values out of them, but at this point we're just declaring their existence and saying here's what we need to work with. And then after we've declared them, after we've created them in this manner, then we can begin to work with them and assign values, retrieve values from them. But most importantly here, I'm telling the computer that I want to assign integer values into those variables. And an integer is really just a mathematical term that refers to a whole number that's within a certain range. So no values after the decimal point. And as far as C# is concerned, the values have to be between a negative 2,147,000,000 and a positive 2,147,000,000. That's the size of the bucket that we have to work with. If you need to work with much larger numbers, then the int data type is not the correct data type for you. There are other data types to choose from, and we'll learn about some of those a little bit later. If we needed to work with like money values where you have dollars and cents or pounds and pence, then the integer is not the right data type to work with. Okay. Let's continue in our application, and this is basically just to continue what we did in Notepad a few moments ago. So x equals 7, y equals x plus 3. And then we want to do a console.writeLine with the value of y. And then remember, we want to do a console.readLine so we can actually see it on screen without it just flashing and going away immediately. So let's run the application and make sure we get the value that we're expecting. And hopefully you got the value 10 in your copy of Visual Studio just like I got in mine. If not, again, make sure you double check your work against mine. All right, so after we declared the variables in lines 13 and 14, then in lines 16 and 17, I'm doing assignment using the equal sign. Now in this case, we don't really call it the equal sign, we call it the assignment operator. We'll learn about operators in the next couple of lessons. This particular operator, the equal sign, means take whatever is on the right-hand side and assign that into whatever's on the left-hand side.